Well, I think the public is fascinated with self-driving cars, and it's because there's such a visceral human response to the automobile. You know, many of us had our first date in a car. For many of us, getting that, driver's license was our first real taste of freedom. So the idea of turning over that authority, that driving authority to a machine, it's a big deal, it's a big step. This isn't an academic exercise when you put a car on the road. Very literally, lives are at stake.
We care about sending our kids to driver's training, right? Why do we do it? We do it so they don't kill people, right? So now the question is, how do we send our cars to driver's training?
So, when you hear the word artificial intelligence, what's the first thing that comes to your mind?
Not real. False.
Aliens. 1000% aliens. Like Mars attacks aliens.
I mean, it's a little scary, but it's exciting.
I guess I think of how computers can make decisions, can be programmed to make decisions like humans.
Yeah, machinery is programmed, but I guess they're kind of the same. But I don't think of software as artificial intelligence. I just don't.
I would say that it is when computers or a robot becomes self-aware and is able to think like a person.
That frightens me a little bit. Not frightened like, oh, just freaks me out a little, let's put it that way. Like, how do you teach a machine to learn?
So the question is, can we develop an AI-powered engine to perceive the world, to make decisions, and have it reach a level of performance and reliability that we're confident in, and confident enough to put it on the road?
The easiest way to think about AI is to think of AI as a box with math and code in it. Now, AI is math and code in a box, the data goes into the box, and decisions come out. And those are decisions about the data.
With classical programming, you're starting with input and rules. So that's what you're specifying and you're getting outputs. And with machine learning, you're starting with examples of inputs and outputs, and what you're getting is rules. That's very powerful because for many problems, these rules are very much non-obvious. They're not something that you could get a human programmer to specify.
So an example of that would be, I want to apply names to photographs. Photographs go in, right? JPEG files go in, and names come out. That's Chris's face, right? That's Chris's mom's face, right? Or maybe transactions, financial transactions go in, and the decisions are, oh, that looks like fraud, that's not fraud, right? Or emails go in, looks like spam, or doesn't look like spam. So the decisions that are important and that affect the way we live our lives, because if my inbox is full of spam, I waste time and I'm annoyed. So it's like a thermostat in the background, right? It is invisibly adjusting parameters of your life to make it easier for you to do something more interesting and not struggle with something basic.
So what is going to happen is AI will become increasingly integral to our lives, to our society. It will become part of the basic infrastructure of society. It will become our interface to the world, to a world that will be increasingly information-rich and complex. AI is going to change what it means to be human.
The application of AI to self-driving cars is the living edge of AI.
It's really a great test of, let's say, whether AI is really ready for the real world.
If we're really going to test and figure out whether we can trust AI, it's going to be in allowing cars to get us where we want to go without killing anybody.
If you had to guess, how does a self-driving car work?
How How does a self-driving car work? I would assume that there's some kind of computers involved, definitely some cameras.
It's more computerized on the dashboard, and that there's probably I don't even know how many cameras would be equipped. I know there's sensors.
You know, I've seen so many commercials about that they can park themselves and they can do this, and my mom has one that'll brake, you know, if the car in front of her brakes, her car starts to brake, and you're like, whoa, that's, you know, a surprise, it's a shock, it's an outside force entering into the environment that you're in that you didn't expect, that you weren't prepared for.
To be perfectly honest, I don't have a lot of ideas as to how all of that gets put into a functional system.
Driving has a lot to do with personality, so it's kind of like telling the artificial intelligence to get a personality. So whoever is running the software behind that, I guess, is teaching it how to drive.
So when we talk about autonomous vehicles and how they work, they all kind of work the same way, regardless of whether or not we're talking about a drone or an automated car, automated train. Any automated transportation device has to develop something we call the world model. So that if you understand what the world around you is, then you then make decisions based on your world model.
Because it can convert raw sensory data into an interpretation that allows you to act. It can be there as an important part of that interface between the car and the world, right? Where it recognizes a stop sign, or a pedestrian, or the lane in a street.
So the thinking part, the decision-making part of any driverless car really comes down to what kind of algorithms were embedded in it.
So an algorithm is a series of instructions for going from some inputs to some outputs.
So when I talk about mapping inputs to outputs, I'm talking about the relationship of one thing to another, the relationship of a face to a name.
So self-driving cars are really just a form of robots on wheels. They use sensors to look at the world and detect what's relevant. It uses algorithms to decide where it's going to drive and how to obey the rules of the road. It's building a lot of artificial intelligence, perception, mapping, localization technology that's all drawn from the robotics community.
And so that's where the big leaps in technology are going to have to come in the next few years, are the development of the perception systems.
So probably the question we get the most is why ducks? We're really trying to rebrand robotics in a way. Our perception is that robotics has a bit of a scary image and a bit of a masculine image. And so that was really the reason to add this sort of element of cuteness. And really the duck was the sort of perfect symbol for that. Duckietown is a scaled down autonomous driving platform that we use for research and education. The only sensor on the Duckybot is a monocular camera, one cheap camera that sits on the front. For the robot to be able to just follow the roads, it needs to be able to take the camera and figure out where the road markings are and then have a feedback control loop that's keeping it in the lane. In a sense, it's doing exactly the same thing that what a current state-of-the-art vehicle does to follow the highway.
Self-driving cars is very much like a problem of scale. So in Duckietown, we all worked on different parts of that problem, and then we all shared our code with each other. So you knew that while you were working on a particular issue, there was going to be updates coming from other people, and by sharing, that was the only way that anyone would have a Duckybot that works.
We can break up the big problem into a sequence of much smaller problems that can all be worked on in parallel, and then merge these things all back together at the end. So this is part of us all working out what the right development cycle and how to most efficiently allocate our resources to do this kind of research and to make the most progress. The big challenge of doing autonomous vehicle research is actually logistic. Getting a car, putting sensors on it, and then driving it around and developing algorithms without running anybody over or putting people in harm's way is a real problem. And so while this makes it seem a little bit unrealistic as compared to a real-life system, it's powerful in the sense that you can demonstrate algorithms by being very confident that you've captured all of the possible input that you're likely to see in Duckietown, and then see how your algorithms actually work.
Like, what was terrifying about that?
On a normal street, like just having the trust that it would be able to see a green light, you know, and be able to know lights are green, or there's a yield sign, or if a cat ran into a street, and it just being able to anticipate all those millions of things.
For me, I do enjoy driving, so the self-driving vehicle would be great to break the monotony of driving, like on a long distance, on a long trip.
The idea of how much people want to invest in self-driving cars or have it, I think there are a lot of social goods to be had out of it.
Do you think that self-driving cars will be better at driving than humans?
I think I'd believe you, because the human reaction time is infinitely slower than a computer's reaction time.
If you have a self-driving car, they're not going to be texting and driving. They're not going to be flipping through the radio. And out of a whole community, I really do believe there's going to be less car wrecks if we use self-driving cars.
You know, we think reactive, and in that moment, you know, do you remember to steer into your fishtail, or do you remember to steer out of it? You know, well, the computer would know what to do, and the computer would think for you. And in that instance, it could help save your life.
Well, the self-driving car industry is really at an interesting moment. We're kind of sewing the parachute on the way down, if you will. There's immense promise in this technology, because you could argue that it's a moral imperative that we should move quickly. We have within our grasp a technology that, once we get it right, we can put on the road and reduce or eliminate the tens of thousands of lives that are lost in the US alone from motor vehicle accidents. So we have to move fast. But the technology, to be honest, is still in an R&D phase. It's not yet ready for productization.
One of the really interesting things about AI is that it gets smarter the more it experiences of the world, right? So you want, as much as possible, to get it out there and exposed to as many things as possible.
Then the rational thing to do, the rational strategy, is to put it into the hands of as many people as possible.
And so the question is, how do we want to do that? Is there a commons, right, that serves the general welfare, right, that we should all contribute to, and that by contributing to, we can ensure everyone's life is better?
And open source is a way to enable this sharing, this collaboration.
And it's looking more and more like this is really a problem that is going to be solved with data, that this is a data-driven problem.
The better the data is that's going into the algorithms, the better the decisions are that they're going to produce. And the better decisions you can produce, right, the more lives you can save in a life and death situation, like a self-driving car.
So self-driving cars collect an immense amount of data. There's data coming from vision sensors at a high frame rate, from these LiDAR sensors, from radar sensors, from the internal motion of the car. It tells us not only about what the world looks like to a very, very high degree of precision, it tells us about what other road users are doing, how they're behaving. It tells us about the conditions of roads. It can tell us about the conditions of trees on the side of the roads.
Most of the big players in this industry have held everything pretty close to their chest.
Well, the data today is really a prized commodity. You know, everybody is putting a fleet of cars on the road with a primary goal of collecting as much data as they can.
And so I think that it's really important that these resources become available to the community at large.
If you're one of the haves with a big fleet of cars on the road and a huge treasure trove of data, you're less incentivized to share But if we think about pushing the industry forward and getting to a point where we have safe technology on the road that's saving lives every day, a way to speed up that process is to share the data.
It's an ethical choice we have to make between the status quo, where we have millions of people dying on the roads, and a better future.
You know, that's why it's so important that people talk about this, to make sure that they understand what the ramifications are of being so secretive, where there's still so much to be learned, that can be detrimental and may not be survivable by any individual company.
Autonomous vehicles is an incredibly ambitious project. So no single company can just afford to develop everything on its own. If we want to get there, we need to be standing on the shoulders of giants.
The question is, will we as an automotive and a technology community get to the point where we can look at each other in the eye and say, it's to everybody's benefit to share this data?
And as a society, because we share these roads, right, and because we're all exposed to the risk of other cars and drivers, we need to be making decisions about how to share the best data with the cars. And open sourcing it can do that. Yeah. Get it out of the lab.